Hi guys, welcome back to another video. The topic for today is combination. Okay, so this is the third video in the list of permutation combination at concept builder level. We have covered the concepts of counting and permutation before this. So if you have not watched those videos, I'll request that you watch those first and then jump to this one. Right? Now without further ado, let's get into it. So see, when we talk about combination, okay, if you remember in the previous one we studied combination, permutation, they are just like a normal operation, right? The way we have addition, subtraction, right, multiplication, division, say we have, say 7 plus 2, 7 minus 2, which is 9, 5, right, 8 divided by 2, which is 4, 8 into 2, which is 16. Similarly, we have 8C2 and 8P2. Right? This is 56. Right? The point being that permutation, combination, they are just another operation. Okay, if you have understood in the previous one, you'll understand or try to understand again. See, permutation, combination, they are not formulas, they are not different theorems or anything. They are simple operations. The way you have addition, subtraction, same way we have permutation and combination. Okay, now last time we discussed that permutations, right, permutations are used to tell us about arrangements. Okay, they tell us how many arrangements are possible. Okay, similarly combinations, now combinations tell us how many selections are possible. Okay, how many selections are possible. Okay, so combination again won't give you the selection that okay, this is the selection. No, that you have to think, but combination will tell you how many possibilities are there. Okay, and how many ways can you select different things. Okay, again, once we understand okay what is combination, it tells us how many selections are possible. Question comes, how do I decide that I need to apply permutation in this question or counting in this question or combination. So remember, right, remember we have first step, we always look at repetition, whether repetition is allowed or not, right? If repetition is allowed, you'll know that we do counting, right? We don't do permutation or combination, we use the concept of counting. If repetition is not allowed, right, then we check for whether the order matters or not. Okay, if order matters, right, yes or no. If order matters, then we use permutation, because that is the question of, right, that is the question of arrangements. Okay, if order does not matter, then we say that we are talking about selections and we use combination to solve the same. Okay, so every time you read a question, okay, every time you read a question, try to figure out, okay, is repetition allowed or not? If it is not allowed, then does the order matter or not? If the order does not matter, then we talk about combination. Okay, now question again thing comes that okay, how do I decide whether order matters or not? Okay, so simple, as I told you previously as well, take a case. Okay, say for example we have 6 students. Okay, I want to make a team of 2, right? So I say that A and B is team number 1. Okay, A and B is team number 1. Now if I interchange the two values and I write BA, does it give me a new team? If the answer to that is yes, then it is permutation because it is arrangement. If the answer to this is no, that AB and BA are same, okay, AB and BA are same for me, then we say that this is a selection. Okay, and that is when we use combination. Okay, so remember, figure out by understanding whether the order matters or it does not matter. Once you figure that out, once you understand that, then you know if order does not matter, then it's a question of selection. Okay, and once we are talking about selection, we use combination to solve the same. Okay, let's look at an example or 3 different questions that will help us decide when to use counting, permutation and combination and understand the difference between the 3. Okay, So again, see, there are 5 students in a batch. Okay, there are 5 students in a batch. What do we want? We want to avoid a prize to the best performer in the quant and verbal test. So we are going to conduct 2 tests for those 5 students. One quant test, one verbal test. Okay, now ask yourself, say you are one of those 5 students, can you win both the prizes? Right? What answer do you think comes? The answer is yes. As a student, I can win the prize for quant also, and if I perform the best in verbal, then I can win a prize there as well. So this is what we call that the variable or the value is repeating. Okay, so this is where we say repetition is allowed. Since repetition is allowed, we will do counting. Okay, since repetition is allowed, we will do counting. Okay, how do we do that? Again, we have done it in the previous video. What do? We make 2 blanks. This is for quant test, this is for verbal test, and I want quant and verbal. Because there is an and, multiplication will come. Now how many options are there for me to give a prize for quant test? 5 options, because I can give the prize to any of these 5 students. Similarly for verbal, again same 5 students, so total 25. Okay, so total I have 25 options. All right, moving on to the next question. Okay, moving on to the next question. Now again you have 5 students in a batch. Okay, same 5 students, but now we are only conducting one test, quants test. Okay, say we are conducting a permutation combination test. Okay, what are we going to do? We are going to give 2 awards. One, a gold prize to the winner, silver prize to the runner up. So the top 2 performers, okay, in that order, will get a gold and silver prize. Now again, think to yourself or talk to yourself, can you as a student get both the prizes? Like, can I get gold and silver both? The answer is no. I can either get a gold or silver or neither, but as same person cannot get both the prizes, right? So this is where, since I cannot get both the prizes, this is where I say repetition is not allowed. Okay, repetition is not allowed because the same value cannot repeat again and again. Okay, all right, repetition is not allowed. So then what do we do? There are 5 students, right? Does the order matter? Think about it. Let's take an example. Now another question or query comes that how do I decide whether order matters or not? So the simplest way to do is assume an example. Okay, assume a live case. Say for example here the students are A, B, C, D and E. Okay, we have 5 students A, B, C, D and E. Okay, scenario number 1, A gets gold, B gets silver. Okay, A gets gold, B gets silver, C, D don't get anything. Now if I interchange, okay, think about, say you get gold, I get silver. Okay, now let's interchange. So it's the 2 of us only getting the prize, but now what will happen? I will get gold, you will get silver. Is it the same scenario? Obviously not, because the price will change, right? Your medal is changing, correct? So when I interchange these 2, okay, when I interchange their positions, is it the same scenario or new scenario? The answer is it's a new scenario, right? Because it is a new case or new scenario, what do we say? The order matters, because the order in which A and B occurred, it mattered, because the moment I changed that order, I got a new scenario or a new case, right? So this tells me that order matters, right? And since the order matters, we will use permutation. Okay, we will use permutation. How will we use that? So that will be 5p2. Again, we'll come in a bit, we'll come to this. How do we get 5p2? What is the answer and all, right? Which is 20, right? We get 5p2. All right. Moving on to the third question type. Again, there are 5 students. Okay, we are awarding 2 same chocolates to top 2 performers. Okay, now we say now the situation has changed. Instead of awarding a gold and a silver prize, what are we doing? We are awarding two prizes, but it's the same chocolate. Okay. Again think, can you as a student get both the chocolates? Again the answer is no, because if you are the first one, you can't be the second one at the same time. So it tells us repetition not allowed, right? Now let's do the same scenario. Okay, say you are the first person, I am the second one. So both of us get the same chocolate. Okay, if we interchange our positions, say I am the first one, you are the second, has the situation changed? No, because we are still getting the same chocolate, right? Think about it. If I do AB or I do BA, right? It's still the same thing, right? It is still the same thing because you're getting the same chocolate. So since both the scenarios are same, right? Since both the scenarios are same, what do we say? Order does not matter. Okay, whether you put A in the first position or second, it doesn't matter. Obviously, first and second matter because it's chocolate versus non-chocolate. But for chocolate, A, B, B, A are the same, right? So we say order does not matter. Order does not matter means we will use combination. So the answer will become 5C2. Okay, again, how the answer comes, how do we solve 5C2? We'll see combination in the next part of the video. Okay, but again, the point is, guys, try to understand. Okay, try to categorize the questions clearly in your mind. Okay, if you are able to do that, your life will become easy. You will know that, okay, I have to think in terms of permutation only, or I have to think in terms of combination only, or I have to do counting, right? Your life will become easier. You'll understand what operation to use. Remember, permutation, combination, treat them as operations, treat them as plus or minus. Don't treat them as any formula or anything. Okay, I hope you understand this. So let's move to the question types, or let's move to, okay, how do I select, or what is NCR? How do I solve it? What does it mean? Right? So if you want to select R things out of N, okay, what does that mean? That I have total N things with me, N options with me, okay, and out of those N options, I want to select only R. Okay, if you look at the previous example that we did, there were 5 students, okay, but I wanted to select only 2, right, the top 2 performers, to give them the chocolate, right? So from 5 I wanted 2. So this N is basically the options that I have. Okay, R, how many I want to select? Okay, so out of N we are selecting R, and this is NCR. Okay, now NCR is simply given by the formula N factorial over N minus R factorial times R factorial. Okay, now if you observe here, okay, we had 5C2, 5 becomes N, 2 becomes R. So 5C2 is 5 factorial over 5 minus 2 factorial times 2 factorial, which is 5 factorial over 3 factorial times 2 factorial. If you solve that, that comes out to 10. Okay. Now another thing that if you guys observe here, you will realize that, see, this much, okay, this much is same as permutation, right? See, this is simply NPR. What is left? By R factorial. Okay, which, if you think about it, kind of makes sense also, right? See, if I want to arrange things, okay, first I need to select, then I will arrange. Okay, take for an example that you have 5 students, right? The previous question that we did, 5 students, okay, gold and silver are the 2 prizes that you want to give. So what will you do? From 5, first you will select 2, that, okay, let me pick 2 to whom I'm going to give the prize. Okay, so from 5 you will select 2. Once you have selected, now you will try and arrange that, okay, the 2 that I have selected, there are 2 prizes, how many cases are possible, right? So arrangement in itself takes up selection, And this is the reason that we as students get confused a lot or make a lot of mistakes. Why? Because we see that some questions are solved using permutation at some places, and some other places the same question has been solved with combination, right? And we get confused, okay, what to use, when to use, right? So for that reason, guys, you will categorize your questions. Remember, repetition not allowed, order should not matter. If that is the case, simply close your eyes and go with combination. Okay, you will get the answer. All right. So as I said, NCR is n factorial by n minus r factorial times r factorial. Okay, formula wise it is very similar to permutation, but again it's slightly different. And why is it different? Because the use case is different. All right, combinations tell us how many selections are possible. Okay, combinations tell us how many selections are possible. Okay, again if you understand this, so we did this in the previous permutation as well. If you have constraints in the question, don't shy away, don't get confused. Constraints are good. What do? We always solve the constraints first and then select the rest, right? It is same as before, right? You will always solve the constraint first, right? And then select the rest. Okay, so it's the same method that we apply for permutation and combination. Remember, it's the formula and the use case that is changing. Okay, permutation combination, the questions will look exactly the same, but it's the use case. In permutation, order matters. In combination, order does not matter. Okay, let's take an example, right, to understand this. Say we have a group of 5 friends. Okay, say we have a group of 5 friends. Okay, we want to make a team of 3. All right, we want to make a team of 3 members. All right, and then we say obviously you have to be part of it, right? Say you are definitely part of it. Okay, so say you are definitely a part of it, right? So then what do? So one, you have selected yourself, so that's the constraint which is over. One person selected for one position, so one person, one position gone. What is left? 4 friends are left, 2 positions are left. So from 4 I need to select 2. Again think about it, the order doesn't matter. I take your name first or my name, or mine and then yours, it's the same thing, right? So that is why 1C1 times 4C2, solve that, that is 4 factorial by 2 factorial times 2 factorial, which is 6. Okay, so even if there are constraints in this, it's exactly same as before. Solve the constraint first, okay, then select the rest. All right, here also the same case works. If it is an and, that is you want a and b, you will do multiplication. If it is or, it is a or b, then you will do addition. Okay, so everything works exactly the same. The formula changes because the thing we are looking for has changed. Okay, all right. Now, before jumping to questions, let's look at some of the properties of combination that can help us solve the questions quickly. Remember, these are some properties and calculation tricks. They are used to solve quickly. Okay, they won't help you, what do you say, understand the question quickly. They won't help you. It's not a trick formula or anything. It is just a calculation trick. Okay, remember, in this entire concept, 50% of the question is solved mentally. Okay, and then the other 50% is calculation. So remember, they will help you solve these things, will just help you solve the question quickly. That's all. Right? So the first property that we should know, right, is NCR is NCN minus R. Okay, that is 10C3 is same as 10C7. Okay, if you solve this, it's very simple. If you solve this, that's 10 factorial by 7 factorial into 3 factorial. That's the LHS. If you solve the RHS, that's, now multiplication, if you do A into B or B into A, it's the same, right? That is why NCR is equal to NCN minus R. What this tells you is that combinations are not unique. Okay, combinations are not unique. Okay, if I want to say that 10C something is equal to something, I should get 2 answers for R. Alright, this simply tells you that combinations are not unique. Okay, next, NCR plus NCR minus 1 is equal to N plus 1 CR minus 1. Okay, let's take an example to understand this. Right. Say we have 4C3 plus 4C2, that is equal to 5C2. Okay, 4C3, if you solve, simplify, that's 4. 4C2 we have already solved, that's 6. 5C2 we already solved, that is 10. Okay, so NCR plus NCR minus 1 is N plus 1 CR minus 1. Right? Moving to the next one, NC0 plus NC1 plus NC2 NCN is 2 to the power n. Okay, this property comes in handy. Okay, when the questions are I want at least one, or I want all of them or none of them, I can take any number as I want. Say for example, I have 5 friends. Okay, or say 5 friends. All right, we want, or I want to invite 0 or all of them. Okay, it's my choice. I can invite none of them, or I can invite all of them, or I can invite some of them as well, right? And the question is, in how many ways can I make these invitations? So what will I say? That okay, what if I decide to invite none of them? So that's 5C0. What if I decide to invite one of them? 5C1, 5C2, 3, 4, 5, right? So if I solve all of it, instead of solving each and everything and then getting to the answer, I can directly write this as 2 to the power 5, which is 32. Okay, so again guys, this is just a calculation trick. If you understand it and if you're able to apply, great. If you're not able to apply, no problem, just solve this. Understanding the logic is more important. Okay, based on this, okay, the next is, what if I remove this NC0? See, NC0 is 1. So if I have NC1 plus NC2 plus NC3 till NCN, that's 2 to the power n minus 1. Okay, this comes from the follow-up of the previous property. NC0 has gone there. NC0 is 1. Okay, so now the same question, 5 students, but this time I tell that I want to invite at least one of them. Okay, I have 5 friends and I want to invite at least one of them. So I'll do at least one means 5C1, 5C2 and so on. That's simply 2 to the power 5 minus 1. Again, this is just a calculation trick to help you solve questions more quickly. Okay, I hope you understand the logic. See, combinations are very similar to permutations. The language of the question, the values, method, everything remains the same. Our approach to the question remains the same. The only thing is, we classify first whether it is a permutation or a combination question, and the formula that we then apply, the answer changes accordingly. Okay. If you understand this, then let's jump to the questions. So we have bakery offers 5 different types of cupcakes. These are the 5 types. We want 4, and each flavor can be selected only once. So remember, the first step that we do is repetition allowed or not. Clearly it says each flavor can be selected only once. That means repetition is not allowed. Okay, does the order matter? Now think about it. You are going to box 4 cupcakes, right? You are going to parcel or pack 4 cupcakes. Does it matter whether you tell that, oh, first I'll have chocolate then vanilla, or vanilla then chocolate, right? The order does not matter. So since repetition is not allowed, order does not matter. That is why we go for combination here. Okay, I have 5 options in total. From those 5, I want 4. So 5C4. Okay, which is 5 factorial by 1. That's 5 ways. Okay. Alright guys, moving to the next one. So we have 7 red, 6 white, 4 blue marbles. Okay, and we need to choose 3. None of them should be red. Again, repetition not allowed. Order does not matter whether I take white first, blue first, whatever I take, order does not matter. So we know it is combination. Right? Now that we know it is combination, what do I want? I want three marbles, but I don't want any of them to be red. Okay. So what are the various cases I can have? So either I can take three white, or basically means addition. I can take two white and one blue, or I can take one white and two blue, or I can take three blue marbles, right? These are the ways I am taking three marbles and ensuring none of them is red, right? So three white means I have six white and I want three, so that is 6C3, or from six white 2 and from four blue 1, or six white 1 and four blue 2, or four blue 3. Okay, if I solve this, that's 20 plus 15 times 4 plus that's 60, 6 times 6 plus 4. Solve that, that is 120. Okay, that is 120. Now this is one way to think about it. Again, as I said, see, this topic is all about thinking, right? You can solve it or make it easy for yourself just by thinking, right? So you can do one more thing here, right? You don't want red, correct? And it doesn't matter what you get, three white, two blue, one white, blue, right? It does not matter. So one thing what we can do is I simply remove red. Okay, what am I left with? Six white and four blue. I have 6 white plus 4 blue, that's total 10 marbles. From these 10, pick any 3. It doesn't matter what you pick. None of them will be red for sure. Right? If you simplify that, that's 10 factorial by 7 factorial times 3 factorial. If you solve it, that will also give you 120. Right? So guys, again, remember, it doesn't matter, okay, the calculation. What matters is how you think about the question. Okay? Moving to the next one. This is very similar to what we did just now. See, we have a band of 4 guitarists and 7 drummers. So total 11 people. A trio. Trio means 3 people, right? Must be formed for a special performance. At least one drummer has to be there. Okay? At least one drummer has to be there. Okay? Again, repetition can't happen because if you are selecting 3 people, same person can't come thrice. Order does not matter. I take your name first, my name doesn't matter, right? So we know it is combination, right? Because it is selection and the way to solve is combination. Same as last time, what can we do? We can either pick one drummer, right? One drummer and two guitarists, or two drummers and one guitarist, or three drummers. We need at least one drummer, right? That then becomes 7C1 times 4C2 plus 7C2 times 4C1 plus 7C3, right? Or as we discussed last time, right? Okay, let's solve this first. That's 7 into 6, 42, 21 times 4, that's 84, and 35. Okay, if you solve that, I think that comes to 161. Right? If you just solve it, that's 42 plus 84, 126 plus 35, 161. Right? Here itself, what could be the other way? Just pause for a second, think about it. I want at least one of them to be drummer. So what can I do? Total cases. Okay, total. So from 11, pick any 3. 4 guitarists, 7 drummers, pick any 3, doesn't matter. Minus no drummer. Okay, if I remove those cases when I am not taking any drummer, the leftover cases will have at least one drummer. So minus no drummer. No drummer means from 4 guitarists, I need all the 3 guitarists. Right, if we solve that, 11C3 is 11 factorial by 8 factorial times 3 factorial minus 4c3 is 4 factorial. Solve this. This is 165 minus 4, which is again 161. Okay. So again, it's all about how you want to approach, how you think about it. Alright. Moving on to the next one. Again, very similar to what we did just now. We have to select a team of 5 employees from 5 males, 5 females, and you should have at least 2 people of each gender. Okay, at least 2 people of each gender. So that means you can have 2 males and 3 females, or 3 males and 2 females. For males, I have out of 5 2, for females out of 5 3, plus, right, which is the same. 5c2 is 10, 5c3 and 5c2 will be same. Remember, calculation trick, NCR is NCN minus R. So no need to solve, you can directly write this as 10. Right, answer becomes 200. Interesting question now. So we have a club of 10 members. We have to split it into 2 groups, one for landscape, one for portrait. Landscape has 7 people, portrait has 3. Jason and Mia must be in the same group. Which group we don't know, but they have to be in the same group. Okay, so this is a simple constraint, right? This is a simple constraint. Again, think about it. Repetition clearly not allowed. Order does not matter, right? Whose name comes first in the group does not matter, right? So that is why this is again a combination question. Now think you are the photographer. You have to arrange 7 people for landscape, 3 for portrait. You know that Jason and Mia have to be together. So how would you arrange them? Right? So think about it again. What can happen? I can put Jason and Mia. So this is my landscape group. This is my portrait group. I can put Jason and Mia here, or right, landscape group, portrait group, I put Jason and Mia in the portrait group. Right, I can have either of the two. Right, so that is how I solve my constraint. Now what do we do? Solve the constraint first. These are 2 people and I am selecting both of them. So that is 2c2. From the remaining, in order to complete landscape, I need 7. So 5 more people. Right? And at the same time, remember, at the same time, portrait remaining 3, I need 3. Right? This is not addition, this is multiplication. Why? Because I need 7 for landscape and 3 for portrait. Because or was here, that is why a plus here. Now for landscape, again solve the constraint first. These 2, I select both of them. From the remaining 8, I need 1 for portrait, because portrait has a total of 3. Remaining 7, all 7 of them will then go for landscape. Right? So this is my landscape, this is portrait, this is portrait, this is landscape. Right? Now it's just calculation. 2c2 is 1. Right? 8c5 is 56. Sorry, 3c3 is 1. Right? 2c2 is 1, 8c1 is 8, 7c7 is 1. So you have 56 plus 8, 64 options. Okay. This is similar to what we did just now. See, we have to make a team of 5 members from a group of 9 members. Now the constraint is, if Leo is selected, Ryan should also be included, and vice versa. That means if Ryan is selected, Leo is also selected. In short, either, right, again, think about it. Say you are the head. What will you do? Either you select both of them or you select none of them, right? What will you do? Say you are the head of the robotics team and you are supposed to make the team for 5 members, and the constraint with you is that Leo and Ryan, they will either come together or none of them will come. So what will you do? You will have two scenarios. Either you pick both of them, right, or you do not pick any of them, right? So if you pick both of them, that's two members who have already occupied two spots. From the remaining 7 members, we need three more. Remember, the team isn't over. Just by picking these two, don't think the question is solved. By picking these two, the team isn't complete yet. You still need three more members, right? From the remaining nine, right? Now, when I don't pick these two, so that means from the remaining 7, I have to make my team of 5, right? If I don't pick these two, I have 7 members left and I still need 5 to make my team, right? That is 1 into 7c3, that's 35 plus 7c5, that's 21. So if you solve, that's 56. Okay, again guys, the point is, think that you are in that situation. How will you navigate that situation? Okay, understand that, and then this is just representation in numericals, that's all. Alright, an interesting question. We have a development company which wants to make a team of director, lead designer, and 4 programmers. So we need a director and a lead designer and 4 programmers, right? So since it is and, it is multiplication, right? Now the constraint, there is one more constraint, right? You have two programmers refuse to work together. Okay, so out of these 4, right, that we select, out of the 7, 2 will not work together. Okay, no problem. Let's again say, think you are that person who's supposed to make this team. Okay, what will you do? We'll come to programmers later. First you'll say, okay, let me get over with the directors. I have 2 options. Okay, I want one, so that is 2c1. Now for designer, right, lead designer, there are 3 options, but again I want one, so that is 3c1, right? Now 4 programmers, right? Now what is it that we want? The two people won't come together. If you remember the previous time when we said two don't come together, what were we doing? Total minus come together. Same thing. Remember, permutation combination, the logic remains the same. It's just the formula of solving, right? The C and P, that changes. So what do I want? For 4 programmers, such that two don't come together, what can I do? Total cases minus the cases when the said 2 programmers come together. Okay, so this remains 2c1, this remains 3c1. Total cases is, from 7 programmers I pick any 4, right? From 7 programmers I pick any 4, minus the 2 have to come together, so those 2 are already selected. Remember, the team is not made yet. I need from the remaining 5 2 more. Now the 4 members of the team are selected, right? Don't just write 2c2 and end. Okay, remember, 2c2 into 5c2. Why this into 5c2? Because the team is not complete. These 2 have come, but the team isn't complete, right? Now if you just solve this, that's 2 times 3 times 7c4, we just solve it, that's 35. 2c2 is 1, 5c2 is 10, that's 6 times 25, 150. Okay, alright guys, moving to the next one. We have Sophia is walking to her friend's house, 8 blocks north, 6 blocks east, only north or east, shortest path. Oh, very interesting question. See, this epitomizes, right, the confusion that people have for permutation combination. Okay, some people might solve it using permutation, some might solve it using combination, and we get confused, right? So I'll do one thing. I'll teach you how to solve this both the ways. Again, as I told you before, and I'm repeating myself, see, permutation combination is all about your thinking. If you think order matters, you will use permutation. If you are someone who thinks order does not matter, you use combination, right? So let's look at this, right? Let's say we look at this with the concept of permutation, right? And here we have combination, right? Now before we solve, let's understand the question. What is happening? So Sophia, say this is Sophia's house, okay? She has to go to her friend's house, which is 8 blocks north. That's 1 block, 2 block, 3, 4, 5, 6, 7, 8, right? And 6 blocks east. That's 1 block, 2 block, 3, 4, 5, 6. Okay. So these are your blocks. Right. 1, 2, 3, 4. Right. Sophia is here. Friend's house is here. Sophia wants to go from here to there. Shortest path means she can't go diagonally. She will either go north or east. Right? She'll only go north or east. Okay. So if she wants to go from here to there, how many steps will she take? She'll take 14 steps. 8 in north direction, 6 in east direction. Right? If you think about it, she wants to go from here to here. What will do? She will do. She will take 6 steps towards east, 8 steps towards north. Right? Could be any way. Right? Say takes this route. Right? If you count, it's ultimately 8 north, 6 east. If she takes some other route, right, like this. Again, if you count, it's ultimately 8 north, 6 east. Right? So now, if you are somebody who thinks, or you are thinking that here the order matters. Order matters in the sense whether I take north first or east first, that matters. Right? So then what will you say? That ultimately this person, Sophia, she has to do 8 times north, 1, 2, 3, 4, 5, 6, 7, 8, and 6 times east. And this can be arranged in any different ways, because every time she takes a different step, it's a new path that she discovers, right? So then that is 8n and 6e, total 14p14. How many ways are there to arrange these? 14p14. Because there is redundancy, divide by 8p8, 6p6. If I solve that, that's 14 factorial by 8 factorial, 6 factorial, right? So if you think, right, that no, every step matters, each step the order matters, right? Because if I take a different step, different thing, it's a new path, then this is what it is, using permutation. Now, on the other hand, if you're someone who thinks that's it, end of the day, she has to take 14 steps to reach, which 8 she takes as north, which 6 she takes as east, doesn't matter. So then what will you do? Let's see, I need 8 north, 6 east. Which 8 does not matter. So from 14, pick any 8. Right? From 14, pick any 8 and say these are my north ones. From remaining 6, pick any 6. Okay, these are your east ones. Right? So from 14, pick any 8. These are your north steps. From remaining 6, pick all the 6. These are your east steps. So if we solve this, that's again 14 factorial by 6 factorial, 8 factorial times 1. Right? So as I said, again, it does not matter, right, what or how you want to approach. Just think what you think is happening here. If you think arrangement is happening, go for permutation. You'll end up with the same answer. If you think arrangement is not happening, selection is happening, go for selection, go for combination. Okay? Right? I hope you guys are able to understand this. Right? This is extremely important because this will clear the doubt in your mind. There is no one fixed way of solving everything. But as I said, if we categorize the questions, it becomes easier for us to approach them. Okay? Moving on to the next one, we have a 12-sided polygon. How many diagonals can be formed? Okay. Again, if you want to make a diagonal, same point can't repeat, right? You need two distinct points, and the order does not matter, because if the diagonal is between point A or B or A, it's the same. The order does not matter, right? So if we think about it, right, there are total 12 points. To make a side, I need to, okay, to now say this is n-sided figure. Okay, I'm not making a dodecagon, I've just made a hexagon, right? For hexagon, total points or total ways to connect these lines, right? Total ways, if you see, to connect these lines, right, my bad, right? This is point 1, this is point 2, you can connect like this, connect like this, connect like this, right, this, right? Pick any 2 points and join them, right? You will get various line segments. Now these are what? These are total line segments. Okay. However, if you see this is not a diagonal. This is side of the polygon, right? Similarly, this is also not a diagonal, side of the polygon, right? So all these corners are sides. So from all possibilities, I need to subtract the sides. The rest will automatically become my diagonals, right? If it is a 6-sided figure, there are 6 sides. If it is a 12-sided figure, there are going to be 12 sides. So that is why the number of diagonals are total line segments minus the number of sides. Total line segments are 12C2. In this case, that becomes 66 minus 12. That's 54. Right? Now, those of you who have already done geometry, okay, you'll know the formula for number of diagonals is n into n minus 3 by 2. Right? This is your direct formula. Now, again, no need to memorize this. If you simplify, right? If you simplify, it's the same. Okay, total line segments are NC2. Total line segments are NC2. Number of sides are N. NC2 minus N. If you simplify that, this is what you get. Okay, so no need to memorize. You can understand the logic. Alright, moving to the next one. We have, there are 10 teams in the basketball league. Each team plays the other team exactly 10 times. Total games played in one season, right? Again, team A plays B or B plays A, it's the same match, okay? Because the question doesn't say home and away, it just says they are playing each other, right? So if you think about it, A plays B or B plays A are the same. Repetition is not possible because A can't play against itself, right? So if I just think about one round, okay, I don't think about 10 rounds, I just think about one round. There are 10 teams, okay? To have a match, I need two, okay? To have a match, I need 2 out of these 10. So if you look at the total combinations, that's 45, okay? So if you look at total combinations, 45, that means if each team plays the other one time, okay? If each team plays the other one single time, there are 45 matches that will happen. Now, don't rush, okay? Read the question. Each team is playing the other 10 times. So the number of matches will become 10 times 450. Alright. Interesting question. So see, we have a community board. We want to make team of 3 members from 5 couples. That's 10 people, and no couple can both be on the board. Okay, how many selections are possible? Again, we know it's a combination question, right? Now, before you start solving quickly, doing 10 C3 that or 10 from 10 take any 3, understand the question. Okay, what is it? There are 5 couples. Okay, let those couples be A1 A2, B1 B2, C1 C2, D1 D2, E1 E2. Right? So these are the couples. These are the 10 people. From this, we need 3. Okay, we need 3, but we have to make sure that from each couple only one member comes. Either one comes or none of them come. Right? So again, think that you are the selection commissioner. Okay, you are the one who's supposed to select. Right? So what is it that you will do? How would you like to approach it? Right? So see, what we can do is from the 5 couples, we can first pick 3 couples. Right? Think of it like a contest. Okay, think of it like a contest. Okay, what are we doing? That from the 5 couples, we are going to advance 3 couples to the next stage. Okay, so instead of directly picking 3 members, right? Instead of directly picking 3 members, right? What am I doing? I'm saying that okay, from 5 couples, let 3 come, right? Say I pick these 3. Okay, so what did we do? From 5, we selected 3 couples. Okay, from 5, select 3 couples. Remember, the team is not formed yet. Okay, from 5 couples, that's 10 people, you have advanced 3 couples, that's 6 people to the next round. Team is not formed yet because you need team only of 3 people, right? But now what you will do is the 3 couples that you have selected, from each simply pick one member, right? From each of these simply pick one member, right? This way you are selecting the 3 members. Okay, this way you are selecting the 3 members. Okay, so remember, see, again I'm repeating myself, the question is all about mental. Okay, mental solving, how you navigate the situation. Always try to think of a practical example. Okay, and then think, how would I navigate in this situation? What would I do? The numbers, the calculations will then automatically follow. Right? Imagine the same thing here. You are the person who's supposed to select. There are 5 couples in front of you. Right? Instead of randomly picking, right, how will you do it? Right? How will you pick 3 members? Right? Couple can't come together. Right? So what do we do? From 5, I first select 3 couples. I send the other 2 couples home. Right? So out of these 3 couples now, I tell them only, or I say, come, like, pick one out of each. Right? So from 5, 3 couples. Then from each couple, pick one member. If you solve that, 5C3 is 10 into 2 into 2 into 2. That's 80 ways. Okay. We have 11 attendees who are shaking hands, right, with every other attendee. How many handshakes are taking place? Right? Again, a very simple question. Out of 11 attendees, right, we need to find how many handshakes are possible. Again, think about it. Repetition not allowed. I can't shake hand with myself. Order does not matter. I shake my hands with you or you shake your hand with me. It's the same, right? So it's simply, I have 11 options to shake hands. I need 2. That's simply 11C2. That's 11 factorial by 9 factorial times 2 factorial, 55. Okay. Again, the point is, try to think what is happening. Try to categorize your questions into counting, permutation, or combination, and you can solve. Alright guys, I hope you like the video. I hope you were able to understand, right, how to solve combinations, how to think about it. That's the more important part, right? Now with these 3 videos, we come to the end of permutation combination concept in total at a concept builder level, a foundational level, right? If you haven't seen those videos, please go check them out, right? Remember, counting, permutation, combination. It's a very simple thing. Majority of the questions will be solved mentally. Okay, categorize the question into types. Do I want to approach counting here? Do I want to approach with permutation or combination? Right? If you understand that, solving or calculations will become easy. Okay, I hope I was able to help you with this. Right? All the best. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and try to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of the series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.